All right, so today we're learning how to solve radical equations. And we're going to learn one method that will basically work whether I have a radical or a fraction exponent, as we'll see in some later examples. Okay, so these steps, you'll need to write these down. The first step is we want to isolate the variable, or sometimes quantity, that has our rational exponent acting upon our variable. That can also, of course, be a radical. So we need to get a radical by itself as well. We'll see this later on. If there happen to be two radicals, then we try to isolate them from each other, or put one on each side. Again, we'll see an example of that later. If necessary, rewrite any radicals as fraction exponents. So for instance, something like the cubed root of x would need to be rewritten as x to the 1/3. Or let's say if I have the square root of x plus 3, that would need to be written as the quantity, x plus 3 to the 1/2 power. Okay, so we're going to rewrite radicals as fraction exponents if necessary. Then we are going to raise both sides of the equation to the reciprocal. So remember, reciprocals are when you flip the fraction upside down. So we're going to raise each side to the upside down fraction power. Okay, and that is everything on both sides. You have to do it as like one big quantity using parentheses or brackets. Then we'll finish solving for our variable and then check for and eliminate extraneous solutions. So these techniques sometimes create kind of false solutions that when you actually plug them back into the original equation, they may not make it true. And remember, that's what we're looking for. What value or values of x make this a true statement? Okay, so let's go through and do example 1. Isolate the variable or quantity that has our rational exponent or radical, I guess I should have added in there, acting upon our variable. So here, this is what we need to get by itself. Okay, so to get this radical by itself, all we need to do is add 2 to the other side. Okay, so now we get the cubed root of x equals 4. So if necessary, rewrite radicals as fraction exponents or rational exponents. So we're going to rewrite the cubed root of x. We don't really need parentheses since it's one term, x to the 1/3 power. Okay, step 3 is to raise each side to the reciprocal power. So I like to use brackets when I do this, but you can use parentheses. So we're going to raise each side to the 3/1 reciprocal of 1/3 power. Okay, and the reason that works here is remember, when you raise a power to a power, we multiply the exponents. And this is going to give me an exponent of 3/3, which is equal to 1. We've essentially just taken our exponent on x and made it x to the first power, which of course is just x. So that's essentially how we get rid of that exponent. Now over here, we do need to perform 4 to the 3/1, which is really just third power. And 4 to the third power is 64. So we get a solution or possible solution of 64, but we have to check whether it works. Okay, so we're going to come back to this original equation. We're going to substitute in 64 for x and see, does this really equal 2? That's a question mark there. Well, the cubed root of 64 does evaluate to 4. And 4 minus 2 is 2. We do get a true statement in the end. 2 equals 2. So now we're sure 64 is the correct solution and a valid solution. So let's try number 2. Once again, isolate the variable or quantity with our radical or rational exponent. Okay, so we need to get this by itself. So think about some things we would need to get rid of here. This 5, which is held actually with addition or subtraction. Right, this is like minus 5 or negative 5, so we'll add 5 to the other side. And then we need to get rid of this negative sign as well. So you can think of that as maybe like a -1 times our quantity that we'll need to divide away. So our first 2 steps, we're going to add this 5 over. Okay, and then we need to divide away the -1, which should really look more in front of that. It's not on the 4 up there, it's just a negative in front. But divide away a -1. And we get the 4th root of x equals -5. Next, we need to rewrite this as a fraction exponent. Well, the fourth root of x is the same as x to the 1/4. Okay, and to get rid of that fraction exponent, we raise each side to the reciprocal 4/1 power. So here again, we're going to get 4/4. This changes my exponent to a 1. We get x to the first, which is just x, and -5 to the 4th power, -5 times itself 4 times, is 625. So let's check this. Obviously a big number to check here, but let's see. -5 minus the 4th root of 625, does that equal 0? Well, the 4th root of 625, you can verify with the calculator, is 5. Oops, so minus 5 equals 0. Well, wait a second. -5 minus 5 more is -10. That does not equal 0. So this is extraneous. It's like a false solution, a solution that doesn't actually make our original equation true. And because there was only one mathematical answer we had come up with to even check and it didn't work, what that means is we have no solution. There's also a mathematical symbol for no solution. It looks like a 0 with a diagonal slash through it. So that basically says no solution twice, but the correct answer for this would be no solution. Okay, so I've copied over the steps again. They're a little smaller and a couple more problems to continue with. So once again, isolate our variable or quantity that has our fraction exponent or radical on it. And in this case, it's important to notice this exponent is only acting on x, not 3. If it was acting on both, they would need a grouping symbol. That's very important to understand, because this is what I need to get by itself, which means the first thing I need to do, or the only thing I need to do to isolate x to the 4/3, is divide away our 3. Okay, so now we get x to the 4/3 equals 81. So this time it's not necessary to write as a fraction exponent. It's already got a fraction exponent. So we can go ahead and skip to raising both sides to our reciprocal 3/4 power. So once again, what's happening with our exponents, if I do top times top, bottom times bottom, we get 12/12, or an exponent of 1. And x to the first is just x. Over here though, notice now we have some extra steps to take. We are going to change this back to radical form to try to evaluate it by hand. So this, remember, is the 4th root, the bottom number tells us which root, of 81 raised to the 3rd. Well, the 4th root of 81 is 3, and 3 to the 3rd, or 3 cubed, is 27. So we have a possible answer of 27 that we need to check. So we're going to plug in 27 to the 4/3 power, so this is from the original equation. Does this equal 243? So we would simplify in the parentheses, which we can't, but do exponents next. And this is the cubed root of 27 to the 4th. Again, remember the bottom number is the root, times 3. So the cubed root of 27 is 3. 3 to the 4th power is 81. And 3 times 81 is 243. It does work out. Could even check that without a calculator. Maybe some of those calculations would be easier with, but 27 is a correct and valid solution. Okay, let's try example 4. So I see that we need to isolate this radical that has our variable inside of it. It is already isolated by itself. If it's a radical, it says write it as a fraction exponent. So let's go ahead and do that. 2x to the 1/2 power. Remember, this is like a square root, so it's to the 1/2 power. Okay, now that we've done that, we do need to raise both sides to the reciprocal power, so the 2/1 or the 2nd power. So on the left, yes, good things are going to happen. We get 2/2 or 1. 2x to the 1st power is just 2x. However, over here, this is x minus 4 times itself twice. Remember, you cannot distribute exponents over addition or subtraction. We actually have to write this out as times itself twice. And yes, you need to distribute that. So if you multiply, we get x squared minus 8x plus 16. Okay, and notice we've got a squared term, a couple x to the first terms, and a constant. We have a quadratic. And so to solve quadratics, remember we want to set it equal to 0, and we usually want to keep our squared term positive. So let's subtract this 2x over. We'll set the left side equal to 0. And we're hoping this is factorable. I mean, worst comes to worst, we could use quadratic formula. But let's see if, minus 10x, if this is factorable. The two numbers, that multiply to positive 16 and add up to negative 10 are negative 8 and negative 2. And so we get two possible solutions here. Positive 8 from that factor and positive 2 from that factor. So we have two numbers for our check. Both might work. One might work and the other might not, or both, maybe both don't work and there's no solution, but we have to check both. So let's start, I'll use different colors here. Let's start with 8. So I have the square root of 2 times 8. Does that equal 8 minus 4? Well, 8 minus 4 on this side becomes 4. Keep everything on their own sides here. 2 times 8 becomes 16, and the square root of 16 is 4. Yep, I agree with that. 4 equals 4, so far I think 8 is good. Okay, let's try 2. So let's try 2 here. The square root of 2 times 2, does that equal 2 minus 4? So the square root of 4, and over here 2 minus 4 is negative 2. Well, the square root of 4 is 2. Does 2 equal negative 2? No, it does not. So 2 is an extraneous solution. So 8 is valid, 2 is extraneous, which means when I'm reporting my answer, we only report back 8. Do not select 8 and 2 if this is multiple choice. That is incorrect. Only one of them worked, and that's another reason why it's super important to check. Okay, example 5 here might be a good one for you to try out. See if you can get this quantity isolated, right? That's got our fraction exponent. Raise each side to the reciprocal power, solve for x, and check it. Okay, pause the video now, try it out, and then we'll move on to number 6, which we'll do together. All right, how'd you do? X equals 3 was the solution to check, and plugging it in, it did work. All right, plugging 3 in here, 3 plus 5 was 8. To the 2/3 power, do that next. That's part of our exponents. That's the cubed root of 8, which is 2, squared, which is 4, times 4, which is 16, plus 1 does equal 17. All right. If you're having difficulty with that, we can go over that in class. So let's go over number 6. This one, if we go back to the original notes, it did say, if there are two radicals, isolate from each other and put one on each side. Okay, so that's what we need to do here. The reason that we want to do that is because even though we can write these both to the 1/2 power now and raise both sides to the reciprocal, which would be the 2nd power, over here, because there's this addition or subtraction, you'd have to kind of FOIL with radicals, like this thing times itself twice and FOIL it out with radicals, and goodness, golly, it gets pretty ugly, right? Don't do that to yourself. Instead, let's move this to the other side. We're going to put one radical on each side, so we don't have that addition or subtraction to distribute, or that we can't distribute our exponent over. Okay, so this gives me the square root of 3x plus 2 equals 2 times the square root of x. So now let's go ahead and write these things with radicals as fraction exponents. This would be the quantity, 3x plus 2. Remember, the square root has an index of 2, so this is to the 1/2 power. And this side is 2 times x to the 1/2 power, where only that 1/2 is acting on x there. So when we go to raise both sides to the reciprocal power, 2/1, both the 2 is getting squared here and the x. So that's important on the right. So yes, over here we're going to get an exponent of 1. 3x plus 2 to the first power is just 3x plus 2. Over here, 2 squared becomes 4. And x to the 1/2 raised to the second, these, just like on the other side, reduce to a 1. I just get 4x. But key part that I see a lot of students miss is they'll leave that as 2x, which is incorrect. That 2 has been squared. It was not originally inside the radical. So let's go ahead and finish solving for x. Here I might move my x's to the left. I think that's going to be easier to isolate x. And then we get 2 equals x. So we need to check positive 2. So let's plug back in. If I plug back in here, would this equal 0? So the square root of 3 times 2 plus 2 minus 2 times the square root of 2, does that equal 0? Well, 3 times 2 is 6 plus 2. 6 plus 2, I guess, is 8. Oh goodness, I don't, without a calculator, this might be difficult. Maybe if I simplify the square root of 8. Well, that's 4 times 2, that's 2 times 2. Aha. So a 2 gets to come out of my radical from that pair, and there'd be a 2 left over. Now, I may not have a calculator, but I know something minus itself will equal 0. So sure enough, yep, I could check by simplifying my radical, putting them in their simplest form, and then if I subtract one from the other, it definitely equals 0. X equals 2 is a valid solution. Okay, so if we write radicals as fraction exponents, like we did there, and eventually raise both sides, and it has to be the whole quantity, like everything on both sides in big brackets or parentheses, to the reciprocal power, we can get rid of those radicals or fraction exponents. Just don't forget to isolate the things with like a radical that has x or a fraction exponent that has x. If it's just a variable, get it by itself. If it's a quantity or expression, like in example 5, get that by itself first, then raise both sides to each reciprocal power and check your solutions. That's it. We'll do some more examples in class.